Hey, my name is Leo, and I'm working as the full stack engineer at the Maker Foundation here in Warsaw. And today at this presentation, we're gonna code debt and look at debt as the basic building block of finance. Let's start with the boring stuff, the disclaimer. All the information presented herein is for educational and informational purposes only. All views are mine. The code presented has not been audited. Do not use with any real value. No content of this presentation should be interpreted as legal advice. I'm not a lawyer, and a lot of topics presented are severely simplified. This is not an investment advice either. After that boring intro, let's go to the agenda and see what awaits us today. So first, we're going to start with why should I care? So what can we build with that? Why do we need those complex and weird primitives? Second, we're gonna talk about Ethereum and what is it and what does it make possible. Then we're gonna go into the differences between the classic contracts and the smart contracts. And we're gonna compare them across different fields and points of view. We're gonna talk about the ERC20 tokens, which is the standard for representing value on Ethereum and for interoperability of value. Then we're gonna look at debt as the simplest contract in the classical understanding, the legal understanding, and see what debt essentially is. Then we're gonna look at debt from the smart contract perspective and think how can we represent debt on the blockchain. After that, we're gonna start coding our basic smart contract that's gonna represent debt alone. And we're gonna go step by step and implement this contract so that it's fully functional at the end. We're gonna analyze the properties of this contract, and we're gonna think of how can we extend the system and how can we build more usable systems on top of the primitives that we've just built in this presentation. After that, there's going to be a small introduction to DeFi and talk about MakerDao and DAI. As you see, some of the topics covered in the previous presentations, but we're going to go deeper here and we're going to touch the actual code and build on top of the ideas presented by Mark in the previous presentation. So without further ado, let's jump in. So why should I care? Like, what can I build with that and what's the problem here? So using the concept described today, different folks have built decentralized lending, borrowing protocols that allow everyone to lend, borrow at the competitive rates and low margins. Not only that, they've built a lot of different products, but that's what we're gonna focus on today. And the current rates on the USDC, and USDC is this token that represents US dollar, are around 128 and 175%. And we see that this is pretty close. There is some margin in the middle, because it's more expensive to borrow than to lend. But at the same time, banks give us much worse of a margin. So for example, in my bank, I get 0.1% on USD for lending and none for borrowing, because there are no credit products available for me right now that allows me to borrow USD, only the Polish zlotys, which is close to 8 to 10%. And also, there are no products available right now that allow me to borrow with just the collateral and no income verification. This is like a completely different type of financial product, and currently this is reserved for private banking clients, but we will build a technical prototype ourselves today, and it will be available to anyone in the world, not just the private banking clients in the developed countries. So just remember, this is just to showcase the technical possibilities. Any legal, financial, or business aspects are out of scope. So Ethereum. Ethereum is currently the biggest smart contracts platform and allows anyone to deploy and interact with smart contracts. The smart contract is basically just a piece of computer code running on the blockchain that can manipulate its state. It is immutable, verifiable, auditable, deterministic, and it's running on the Turing-complete virtual machine. And Ethereum allows us to run this virtual machine on the blockchain. So how does the smart contracts differ from the classical contracts? And how can we compare them? So when we look at the paper contracts and smart contracts, we can compare them on different fields of comparison. Let's start with the logic. Smart contracts use Boolean logic. It's either true or false. There are no shades of gray, and there's always certainty. In the paper contract, there's always room for interpretation. Did something happen or did it not? Or what did they mean by using these vaguely formulated words? This has its pros and cons. Predictability. So paper contract is very flexible because it was designed to describe the human interactions. And smart contracts are very rigid, even in case of bugs, because they were designed to be that way. And this is their benefit, but it's also a con. Dispute resolution. So when something goes wrong, what happens with the smart contracts is code is law, and things go as they were coded. And there is no dispute resolution. Like, if you've made a mistake, this is your problem. In the classical world, we have a well-established dispute resolution procedures. You can go to court and you can argue that you've made a mistake. You can revert a contract, which you can do with smart contracts. But there are some people working on some dispute resolution protocols, and you can build dispute resolution on top of the system. You can think of that in terms of soft promises versus hard promises. So paper contracts give you soft promises, and if you want to harden those promises, you cannot do that. But smart contracts give you hard promises out of the box, but then you can build soft promises on top of that. Trust. In the paper contract world, trust is required, but not a given. But in the smart contract world, trust is mathematically built into the system, and you don't need to trust the party with whom you contract, because you know that here is the code and it will be executed like it's written. There is one important point here, that smart contract and regular contracts can be actually combined. Smart contract can be part of the regular contract, and smart contract can allow you to execute some operations in an automated way. So those are not completely separate things. They can intersect in some cases. Let's look at a smart contract, like what it is essentially. Not smart contract, but classical contract. Every classical contract is a set of obligations called contractual obligations. So if X, then Bob is obliged to do Y. If Bob fails to do Y for whatever reason, Alice can take legal action and the state can make Bob do Y. So this is the basic schema of what the contract in the legal understanding is. When we look at the smart contract, it's completely different. Smart contract is a set of computer instructions and conditions that change the state of the system. If X, then 10 units of Bob's balance are transferred to Alice. Note that Bob is not obliged to transfer and cannot prevent it from happening other than somehow making sure that X is false. So this balance is just transferred on demand of Bob, where in the first case, Bob was obliged to do that, and Bob could just deny to do that, and that will delay the process by a lot. ERC20 tokens. So in order to do something useful on the blockchain, we need some standards so that we can understand each other. Standards introduce interoperability, and one of those basic standards on the Ethereum blockchain that is very popular and useful is ERC20 tokens. ERC20 token is basically a contract that implements the provided interface. Don't be afraid now, we'll go through each line by line, and I'll explain what does this interface mean. So whenever the contract implements this interface, we can call it an ERC20 token, and then we can operate on it as a token. And there is a lot of different tools that can understand the standard and make use of the standard. Our contracts that we will code today will also base on the standard, and that's why we're talking about it right now. So the first function is total supply, which basically returns the amount of tokens in circulation. The second one returns the balance of the account. Nothing complex here. The third one allows us to transfer tokens to some address. So from me to you. I call this function. That's why there is no argument for me, because the blockchain knows who called the function. So there is an argument for the recipient and for the amount of token being transferred. And then there is also an allowance mechanism or approval mechanism. And to understand that, we need to understand why is it here and why do we need it. So we have our tokens and we can spend them. That's cool. But we want to use them in the more complex scenarios. We want to code systems of smart contracts that operate with those tokens on our behalf when we allow that to happen. So that's why we want to approve those smart contracts and give them the allowance so that those smart contracts can spend our tokens. This will allow a lot of different use cases. One of the use cases will be described today, but for now, we'll just remember that the approve function approves someone to spend some amount of my tokens. And in case this someone in the is the smart contract, we can read the code of the smart contract and understand exactly the situations when they will spend my tokens. So my tokens will be secure because there are some preconditions before they can spend them. And the second function allows them to spend them. The second function actually checks the allowance. It's the getter. And they can also not spend more than the allowance I've given them. So even if something goes wrong, I don't lose all of my money, but I can lose up to this amount. So this limits the risk. The third function allows someone else to execute the transfer on our behalf. So if I've given them allowance, they can call this transfer from function, just similar to the transfer function, but the caller is actually not the owner of the token, but the operator, so-called, of the token. So now that we understand the ERC20 tokens, we can look at debt as the simplest contract in the legal system, because debt is just one obligation. Here we have the most basic contract. Obviously don't recommend using it, but this is the structure of the most basic debt contract. You have two parties. You have the lender and you have the borrower, which are contracting together. You have the date, you have the loan amount, and you have the date by which the loan should be repaid, and the repay amount, which is usually more than the loan amount because you need to pay to loan the money. This is the fee. And there are the signatures of the lender and the borrower that they agree to that. So this is the basic structure. And assuming that Alice transferred the funds to Bob upon signing, this defines just a single obligation for Bob to repay the debt on time. If Bob fails to pay back his loan, Alice can sue Bob and upon winning, ask the government to seize Bob's assets. So we see how it works here. They agree, and then Bob has an obligation to transfer. And if he fails, then the only thing Alice can do is go to court. But then debt as a smart contract should be different, because in smart contract world, we don't have courts, and we cannot just seize real world assets. So we need to think how to be secure without relying on courts, how to be secure with relying on the blockchain and the mechanisms that it gives us. So we need to have collateral to protect against damages, because let's look at this contract before. What happens if Bob doesn't pay his loan on time? Then Alice is owed 105 USD, and if Bob doesn't pay, this is Alice's damage, like she just lost 105 USDs. But if we have collateral, we can protect against that. Hopefully, not hopefully, but our damages are limited in the case of the debt smart contract, because the maximum amount that Alice is owed is 105 USD, because as soon as the loan is due, she can get back her 105 USD from the collateral. In the real world, it's not like that, because if Bob doesn't pay on his obligation, then there are some fees on top of that, so that the damages are not limited. But in our smart contract world, all is good. Let's go into the actual code and start to implement the basic loan in Solidity and see how we can implement the basic building block of the finance, manually debt, on the blockchain. We'll start with the empty smart contract called BasicLoan, and then we describe the terms of our loan. This is the structure where we store the data about the terms. So there is a loan amount. Loan DAI amount is because we will be using the DAI token for that, and DAI token is soft pegged to USD. So basically this loan will be in USD. And we will be using Ethereum as the collateral. And as we've talked before about the Ethereum is the native token of the Ethereum blockchain and also has its value. So someone will be lending DAI and putting ETH as the collateral. So we have loan DAI amount, fee DAI amount, ETH collateral amount, and repay by timestamp. And we store the structure in our storage on the blockchain to access it later. We also need the enum for the loan state because there are different operations you can do on this loan. You can fund it, you can liquidate it, you can repay it, and some of those operations are allowed only in some states and not allowed in other states. So we need to track which state are we currently in, and for that we declare this enum. We see that there are 5 states actually: created, funded, taken, repaid, and liquidated. But in the last 2 states, the contract will be destroyed, and that's why we don't describe those states here. The next step is the modifier. The modifier is similar to a middleware. It is this function that can be executed before the other function, and it can check some preconditions. This is the simplest modifier, and it just checks that we are in the expected state and throws otherwise. Some other state variables that will be useful for us is the lender address, the borrower address, and the DAI address. DAI being this token that represents the US dollar. So in the constructor, the one who deploys the contract passes the terms and the DAI address, and we record all of that in our storage to use later. We also record the message sender as the lender and set the loan state, the initial state, to create it. Let's look at the first function. The first function will be used to fund the loan. It will pull the funds from the lender. It will pull the DAI tokens from the lender and lock them into the contract, and those funds will be available to borrow later. So this function will be executed only in the state loan created, because we cannot fund this contract twice. We shouldn't be able to. And we set the state to fund it, and we pull the tokens using this transfer from function that we described before in the ERC20 standard from the message sender to this address, and we pull exactly this amount of DAI. Here it's important to understand what happens in the blockchain if there is an error. So if there is an error, the transaction gets reverted, and all the state changes that happened before also get reverted. So it's a very secure approach and a very rigid approach, but it allows us to not care about state cleanups and things like that. So here, for example, what happens if the lender does not have enough DAI? If loan DAI amount is more than the lender's balance, then this transfer from function will just fail, and our state will be reverted. So the lender later can get more DAI and try this function one more time. Second function is take a loan and accept loan terms. It's only in the funded state, and we first check that there is enough collateral sent to this function, because when we call this function, we send Ether to it as the collateral, and this Ether gets locked into the smart contract. And we throw if there is not enough Ether, record the borrower, record the state, and actually transfer the DAI tokens to the borrower, therefore granting the loan. Third function is the function that's used to repay this loan. So whenever we can repay this loan, we check that the message sender is the borrower. Why do we need this check? We need this check because in the real world, if anyone repays your loan, you're good with that. Like, why would they? But it's good for you. Here, when they repay, they get the collateral back, and you don't want that. And that's why we check that the borrower is the message sender, because the collateral amount should be actually more than the loan amount. And when we check that, we send the DAI tokens from the borrower to the lender, including the fee. And again, this will fail if there is not sufficient DAI tokens. At the end, we call self-destruct on the borrower address, and self-destruct will release all the collateral. It will transfer all the Ether back to the borrower. Liquidating the loan. So this function is called by the lender to liquidate whenever the loan is not paid. And we don't need to sue anyone or do anything complex. We just call this function, and the whole collateral is put back to the lender, so the lender doesn't lose any money. So we see here, side by side, this classic contract and the smart contract. Obviously, the smart contract is more complex, but it's still 50 lines of code, so nothing critical. But it executes automatically, and there is absolutely no trust requirement here, and no court system, no requirement. So you can use this contract to borrow from someone from across the globe. You don't even need to know them. You just need them to accept this contract and interact with them. And if they don't pay back the loan, you just liquidate their collateral. So that's the beauty of the smart contracts. Let's look at the properties of the contract that we just coded. So it has fixed rate, interest rate. There's basically no interest there. There's just the fee, the provision for granting this loan. It has fixed term because we have the fixed timestamp. It is over-collateralized because in order for it to work, we need more collateral than the loan amount. Otherwise, if someone doesn't repay the loan, then liquidating the collateral will not help us. It has the single lender and the single borrower, and the borrower needs to be known beforehand, but he doesn't need to be trusted. This is interesting, but we need to go deeper. We need to build something more useful, more real world. This was just a demonstration of the power of the smart contracts. So let's design something called a lending pool. A lending pool is the system of smart contracts where you can borrow to the system and lend from the system. And you can borrow and lend at any time and any amount, assuming there is enough liquidity. And lenders don't need to know borrowers, and they don't need to trust them. It would be nice for lenders to always be able to withdraw, but given such a guarantee means that nothing can ever be lended for any amount of time. So we will slightly relax this guarantee to build a practical system. A lending pool is actually similar to a bank. Like you can go to a bank and borrow money, and you can go to a bank and deposit money, and some other clients do the same, and you don't need to know them. For you, it's just a useful financial institution. And something similar can be built on the blockchain. So let's think, how can we build it with the knowledge that we already have? The mechanism that we will use here is different interest rates, basically the same as banks use. And we define something called the target utilization ratio, let's say at 80%. And our system has some assets in it. And let's say that the target for our system is that 80% of assets on average are borrowed and the other just stay there as the reserve. And whenever this target collateral utilization ratio goes up, our interest rates also go up. And that means that it's more expensive to borrow. So people who borrowed before will start to return their loans and repay them, which will bring the utilization ratio down. And the other way around on the other side of this curve. If not enough people borrow, then it becomes cheaper to borrow and it incentivizes people to borrow. So there will be always this balance in the system. And even in the case, if there is not enough reserves for some huge lender to withdraw the funds that he wants to withdraw, he can always wait because he's getting a huge interest rate on these funds in this situation. And that is the relaxation of this constraint mentioned before that we're going for in this system. So this is one of the most popular products in the DeFi basically right now. People are just lending and borrowing money between each other. And what is DeFi? So DeFi generally refers to the digital assets and financial smart contracts protocols and decentralized applications built on Ethereum. In simpler terms, it's financial software built on the blockchain that can be pieced together like money legals. So you can combine those contracts together. You see how before we talked about the token standard, and then we built a loan on top of the token standard, and then we built this money market on top of the loan concept and the collateralization concept. In the DeFi, you can combine protocols like that together to build new, more interesting protocols. Here are some examples of the products that either exist or can potentially be built on the blockchain. You can build multiple types of loans, over-collateralized, under-collateralized, different terms, whatever you code. It's a Turing-complete programming language, whatever you can imagine. When you can build loans, you can build leverage for trading. So you can short some tokens and you can long some tokens. You can build exchange traded funds. You can pull some assets into the baskets and trade them together. You can build trust funds because you can add any constraints on how the money can be spent and how the assets are managed. You can build lotteries for people to gamble. You can build no-loss lotteries. No-loss lotteries is basically where people pull the funds together and they get some interest, and the price that they get in the lottery is this interest from all the funds pulled together, but they get back the ticket every time. And this is an interesting concept that is implemented on the blockchain, and you can try it. You can build option contracts. Options are those financial instruments used in the markets that allow you to have an option to buy some asset at some price in the future. And with the smart contracts, you can build something like that. And you can also build prediction markets. Prediction markets is a concept that allows you to bet on the outcome of some real-life events. Maybe this is a lot of information to handle, but I'm just leaving it here right now, so later you can Google and explore the uses of smart contract that interest you. So DAI and MakerDao. MakerDao is a decentralized organization dedicated to bringing financial stability and transparency to the world economy. MakerDao enables the generation of DAI, the world's first unbiased currency and leading decentralized stablecoin. DAI mitigates volatility through the autonomous system of smart contracts called the Maker Protocol, as well as through the centralized community governance. As DAI is backed by a surplus of collateral that has been individually locked into an audited and publicly viewable Ethereum smart contract, anyone with an internet connection can monitor the health of the system anytime at DAI stats. And why is it important? It is important because as soon as we have the dollar on the blockchain, all of those financial applications become interesting and become usable. Because if someone can loan Bitcoin using Ethereum as the collateral, that's funny, but that's not useful. And no one will actually lock a lot of value into that because there is a lot of volatility. And DAI is this most basic building block that allows to build actual financial systems and actual financial applications on top of the blockchain. So let's go back and see what we went through today and what we discussed and sum up. So first we talk about what can be built on the blockchain, on the Ethereum, and why should I care. Then we talked about the Ethereum and the differences between the smart contracts and the classical contracts. We described the ERC-20 standard. We looked at debt as the single obligation contract, the most basic classical contract. Then we looked at debt and how we can implement it as the smart contract. Then we've done this implementation in Solidity step by step, analyzed the properties of the contract that we came up with, talked about the concept of the money market and how we can implement something like that using smart contracts, talked about DeFi and DAI. Thank you for your attention today, and I'll now go to the questions, and we'll be happy to answer your questions.
For some questions, it took solid 20 minutes to ask questions in the comments after my presentation. So I was trying to answer all of them in the comments as well. So let's spend a couple minutes. We can iterate through some of the questions. One of the questions was why Solidity not using already existing language? Leon, would you like to explain a little bit?
Yes, this is the question that comes up a lot, and the short answer is because the platform is so different and the constraints on the platform is so different. Solidity is similar to other programming languages in terms of syntax. Like when you look at the code, you basically understand what happens there. It's similar to C++ or Java or JavaScript or whatever you're used to. But the concept underlying the language are very different and they're very blockchain specific. And in the computer world, whenever a wholly new platform comes up, there is a new programming language. So for example, why JavaScript for the web when we had all the other languages before? Because the browser is so different. And they're trying now to do WebAssembly and Dart and all the other stuff, but doesn't work that good. Solidity obviously has its pros and cons, but they needed a language that is suitable for the blockchain. And blockchain has a lot of constraints like gas or the storage model, because the storage is very different from what we see in the classical computing.
Yeah, I think it's a great answer. And I actually, so we have actually questions about Leon presentation, first two. Leon, can you see? Well, let's read it.
How can we be sure?
Sorry, go ahead.
How can we be sure that we get our tokens back when we borrow them? So we can be sure that we get our tokens back, but we can't be sure that we will not lose money as long as collateral's value is more than the value of the tokens. So that's why we're talking about the collateral. So for example, if you're borrowing 100 USD and given 150 USD as the collateral, and then you don't return this 100 USD, then your whole collateral gets liquidated. So the lender gets 150 USD instead of the 100 that he borrowed, so he's happy. You're not happy, but you defaulted on your obligation. So there is obviously this trade-off between the amount of the collateral. So the more collateral you put, the more secure is the loan, but also then like you need to have more collateral, which is a downside.
Before we answer the next question, I want to say I just look at statistics on Facebook, and we have almost 200 people who are watching today. So thank you very much. And we can go to the next questions. Are there any other than Ethereum DeFi-friendly blockchains?
There are some competitors at different stages. I think Ethereum is definitely the most popular and the most user-friendly and developer-friendly right now. And it's number one by the volume, by the transaction amount, by the fees. But there are some other like Ethereum killers, and they have a lot of interesting ideas, and it's interesting to watch them. And maybe at some point they will take over Ethereum, maybe not, we'll see.
Yeah, it's difficult to predict. As of today, Ethereum is by far the most active DeFi and developer community, but there are people building all the time, so it will be really interesting to see how it unfolds. We have a next question, I believe, a general question from my team. Why would you want to borrow 0.5 ETH by giving one ETH collateral if you can use your original one ETH to start with? It's a good question. I think you want to borrow 0. worth of ETH by giving one ETH collateral would be the right way to phrase it. Yeah. Leon, you want to answer that?
I can answer that. So you wouldn't want to do that, but you would want to, if you have Ether, then you have this money in Ether and you can't do anything with that. And if you want some liquidity, for example, you want to buy a car or you want to pay some bills, then you need to sell this ETH or you need to take liquidity from someone else. But here you can basically borrow some amount of this Ether in DAI and use this money somewhere else whenever you need liquidity. So it's similar to the mortgage when you think about it. When you buy a house, you put 20% down and the bank gives the other 80% and you're the owner of the house. So you put the house as the collateral and the house's value is, for example, 100,000 K, but then your loan is 80,000 K. So it's also over collateralized because the value of the collateral is more than the value of the loan.
Mm-hmm. We have more people. Maybe I'm going to answer that one. Do you have some experience with Polkadot, guys? Can you tell us something about it? So Polkadot is a great upcoming blockchain from similar community than Ethereum. Those guys were building Ethereum node before, and it's a great team. We have a lot of great friends there, and there are many Polish people working there as well. So we are huge fans. Polkadot has an idea how to scale a little bit better by building blockchains of blockchains. So you have blockchains and multiple other blockchains connected, and they can interact with each other in fully permissionless way without the need for trust. So Polkadot just launched the mainnet a couple months ago. So they're very, very fresh and new. They're kind of a new kid on the block. They were a long way coming, but very, very recently they launched. So there is a lot of community, there is a lot of development, a lot of big developer community, much smaller than Ethereum, but I think second biggest after Ethereum still. And it's really exciting. We've done at Eatworks a couple projects in Polkadot ecosystem that was mostly building blocks of Polkadot ecosystem itself. So it's not yet really, we don't really see working projects yet. A lot of people building. So we expect in a year or two, there might be some very interesting projects coming. Yes, there's more questions coming. I'm gonna read that one and let Leon answer. Maybe after implementing EWASM, so Ethereum assembly, it will. Yeah, you, Leon, explain what EWASM is, and we will be able to use more favored languages. What do you think?
I hope so. So EWASM is this idea / proof of concept, maybe more now, that we can use not the Ethereum virtual machine, but the other virtual machine, similar to WebAssembly on the Ethereum. And that will allow us to have the more like normal compilation target, and all the languages that can be compiled to WebAssembly will be also able to be compiled to Ethereum. There are obviously a lot of asterisks, but there is some work happening on it right now. I personally haven't tried EWASM, but I've tried WASM and tried compiling something to WebAssembly and run it in the browser, and it was nice and good. Don't use it in production yet, but why not in a couple of years?
I think it's also important to understand that the language is not that important. You need to understand the new programming model, which is slightly different. It's not completely different if you know how to program, web or mobile or something, and you understand how programming works, the algorithms, the basic understanding of how computer works, databases, this kind of stuff. You can learn Solidity in just, I think, couple days, maybe a couple weeks tops, if you put your heart to it, especially. So it's more about different programming model, like the memory model is different, the pay for execution model, those are different security considerations that you need to take into account. So this is important. The language is really secondary. If the Java or Solidity or whatever, you ain't gonna program in Java like you know it as of today, because it's gonna have different memory model, because it's gonna have different security considerations, because it's gonna be need to deterministic. And that's going to make it really something Java-like rather than Java itself or C# or whatever your favorite question is. And I think there is also a question about Viper language. Have we tried Viper language? We tried Viper language. It's fine. It's a little bit better than Solidity. And the truth is, it came just too late to make to the blockchain mainstream. It's a little bit better than Solidity, but already so many people knew Solidity and so many products were written in Solidity, and all the auditing firms were doing Solidity, so that people didn't switch. And I think Viper is now a ghost language. I don't think anyone is using it. No, I know 0 projects that are using Viper language. Woo! And the questions keep coming. I see 3 more questions. Let's do those 3 more questions, and feel free to ask more questions right after that, because we're gonna have a networking party, virtual networking party. So let's answer the last 3 questions. What are now the possibilities for storing large amounts of data on the blockchain? Leon, you wanna take that one?
Yeah, I can take this one. So depends on what we call the large amount of data. If we call like a couple of terabytes large amount of data, or petabytes, then your only solution is the private blockchain, and the public blockchain is just not a tool for this task. If we're talking about a couple of megabytes, then it depends what you want to do with this data, and how you, do you want to retrieve it from the smart contract, or do you want to store it and retrieve it from the outside? Because there are basically 3 storage mechanisms on the blockchain. You can store data in the so-called storage. It is very expensive, but you can read it from the smart contract and it's available and it's indexed. You can store data in the logs, and after the transaction is executed, those logs are stored on the nodes. And the smart contract cannot read the logs, but the client and the light client can easily read the logs. And you can essentially also store data in the call data. So when you call the contract with the arguments, those arguments get recorded on the blockchain. They don't get indexed. It's hard to iterate over them later, but this is the cheapest storage method by far.
Yeah, I would add there is a good story on one hackathon. One of the teams wanted to build storage on blockchain for things like persistent permanent storage, and they calculated that if you get a Lamborghini photo in high definition, it's gonna cost more to store it on the blockchain than buy the actual car. So yeah, blockchain is very expensive to store data, and it's probably not a good place to store data. And but it's really good at doing different things, like in security and trust, right? So the things you want to build on blockchain are the kind of things that are trust heavy and not very big in sense of storage. And that's why the very first thing that kind of that is right now happening on the blockchain is decentralized finance, because it has exactly those properties. And then someone said, okay, what about private blockchains? Yeah, this is a different kind of animal, private blockchains. And I think it gets mixed a lot because, blockchains, public blockchains, it kind of sounds the same, but it's a different thing. In public blockchain, you have this trust that comes from the system, economic incentives and all that stuff, right? A private blockchain is more like there is a committee of people that tell what the truth is. Therefore, there is not a lot of disruption to be done and new stuff to be built on private blockchains. There is not such a potential as in those public blockchains. We do expect that private blockchain is going to improve a lot of processes in corporations and collaboration between different companies. So we can think about it as a little bit more secure cloud, something that allows those companies to improve the processes. But we don't expect like DeFi to happen on private blockchain. That's just something that doesn't happen. Private blockchain is something by definition built for companies to optimizing other processes in the company or across the companies. I don't know if Leon is agreeing with me. Maybe I'm exaggerating a little bit. No, I think that's not very controversial. And last but not least, I would like to say that continuing on the topic, someone said IPFS for storage. Sure. So a lot of those applications that want to use decentralized stuff, financial institution. Yeah, we would like also to have some pictures. Like we would like to have avatars of people or whatever else. Right. So for those people, there is a new category of technologies that being developed called distributed storage, and IPFS is the oldest one, the most well-known, but there is a Filecoin that is actually related to IPFS, but there is also Swarm. There is at least 2 or 3 other platforms. So if you want to build, your Facebook on blockchain, then probably very little of that Facebook gonna be on blockchain. The majority of that gonna be somewhere on distributed technologies, and in fact they are very young and they're just starting out. I think IPFS and Filecoin launched again 2 months ago or something, right? The IPFS is an old system, but the incentives around it that allows you to store permanently or persistently. There is a slight difference between those words. We're not getting into it, but in a way that it stays in the network for a long time. I think there is. I think they launched a month ago or 2 months ago. Leon, can you correct me here?
No, I wasn't following, but it was a short time ago. Yeah.
So it was short time ago. So those things are all things to be built in the future. So now it's all about DeFi. But once the DeFi space gets a little bit colder and more stable and slower growing, which I expect gonna take a couple of years because it's super hot and it's gonna take a little bit of time. that's gonna be a next thing to be disrupted by distributed technologies. But we're probably at least a couple years away from that. It's like, even if today someone is building, before it's going to be stable, before people are going to be using it, it's probably those are not easy projects to build. This is not web. This is not like 3 senior developers, 3 months, boom, you have an MVP working. It's a lot of try and error, discovering, researching, learning, and only on the other side, with some probability, there is a success. So, yeah, did I say that was the last question 3 questions ago? So Mateusz, let's do this. Last question. I'm gonna read it, Leon. I hope you're gonna answer it. The only incentive for users to balance DAI supply from market mechanism perspective is an arbitrage. I mean, to buy on the market DAI and pay the collateral or issue DAI and sell on the market. I'm not sure if you follow the question.
Yeah, that is basically true. And that is called soft peg. And it's not the hard peg as some other stable coins have. So for example, let's compare DAI to USDC. With the USDC, you have the US legal entity, and you can transfer USD to it, and it issues USDC using the rate 1-to-1. And then you can also redeem those USDC for USD and get US dollars back. And it's a very nice system in its properties, as the price of the USD is always 1, because as soon as it goes like even slightly up, someone can arbitrage a lot of it. But the problem is this US legal entity. It should be trusted. And if it defaults, goes bankrupt, then those USDC tokens are basically worthless, because there is no entity that can redeem them back for the USD. DAI has a soft peg, which means that there are market mechanisms, as you mentioned, that bring it to the $1 amount. And if DAI is slightly above $1, then you can arbitrage and do some things to put it back to $1 and the other way around, which results in DAI not always being worth $1. Sometimes it's slightly less, sometimes it's slightly more, and it depends on the amount of liquidity. But the system gets bigger and bigger, and the system gets more and more liquid, and we're making a lot of progress. So with time, it will be more and more stable. But it is secure. It is more secure than USDC because DAI is fully decentralized, and yeah, there is no US legal entity behind that just storing all the dollars.
Wonderful. So thank you for that last question. I see more questions are coming, but our time is up.
But last question about what can we recommend for the junior Solidity developers?
Okay, then let's do one more. So, I guess one question is junior Solidity developer is a tricky position to be. So if you're a junior developer in general, my advice would be to go through another specialization into blockchain, for example, for front-end development. Because Solidity developer, there is a difference between coding, let's say, banking application and coding blockchain application. If you do a banking application and there is a bug, and let's say $1 million gets randomly transferred to the wrong person, then there is the whole banking system. Transactions are reversible, and there are different ways you can undo what have been done. If that fails for some reason, there is the whole legal system, and you can, go to court in the extreme cases, and fight person to get the money back, right? But it's a little bit different on blockchain. If you make a mistake on blockchain, if there is a bug, it can cost. You can lose millions of dollars, and there is no way to revert the transaction. There is no way to undo the damage, and oftentimes those are anonymous people. Not always, but oftentimes anonymous people, right? So you probably want to have you want to feel pretty confident about your skills. What are the ways to get more confident about your skills? Well, first of all, continue joining 0x Poland, join one of our workshops, and It's going to be us, it's going to be Maker people, it's going to be other people as well watching the group and looking for people to hire. And even if you don't necessarily, there's a lot of work in Solidity, there's a lot of work in front end and tooling that requires basic Solidity skills to do. So those are great ways to get into it. If you're a little bit more experienced developer, then getting into the space should be fairly easy. And like just learning another language. If you know any language good, it's not really hard to learn another one. So just take some time off, learn the language, make sure you understand all the details about security and so on. And I think there's plenty of jobs in the space. With that positive message, we will end our transmission, but it is not the end of the event. Please, again, come. I will answer the following question on our networking group. Can we see the networking link once more? Yes, I see people joining. Mateusz, who is doing, yes, this is the link. Join us there, ask any question you would like, and we would love to answer. We'll be hanging out there. There are different tables you can join. You can see where the different people are sitting. Just click on the table, join the discussion, and we'll be happy to answer any questions you might have. It was absolutely wonderful to talk to you today. Leon, thank you very much for coming. Thank you for the great presentation. We were overwhelmed by the amount of people that were watching this first episode of Zero Exponent. We hope to see you again in a month. We hope to see you on workshops and ultimately on hackathon as well. Thank you very much, and see you on Remoko. See you on Remoko, which is the virtual networking thing that we're going to right now. Thank you very much. Thank you, Leon. Bye-bye.